Welcome to the session on serverless Spring. I'm very happy to have Dave join me on stage. It wasn't part of the original plan, but now he's going to be covering much of the Spring Cloud Function project itself, which he's actually been more involved than me since we started the Riff project. And Dave and I have a long history of co-presenting. We've had classics such as the enterprise integration talk that I like to think of as you say router, I say router. And then the concurrency talk where we had synchronizing shared access to a small stage, and I almost fell off the back. So I'm glad to see there's a railing here.
We've tried various different combinations of keyboards and laptops over the years, and normally I force him to use mine. And this time he's persuaded me to go the other way. It's his show, so that's fair, right? I'm using his laptop, but I got my own keyboard. So fingers crossed that's going to work. If anything goes wrong, it's going to be like, AVs basically working out where your fingers are when you need them. So yeah, thanks for coming, and I apologize for crashing the party. It wasn't my party, but Mark invited me, honest. It's great to see you all. Wow. You could have gone to so many other talks, and you came to this one. So why don't we get started?
Sure.
Yeah.
Okay.
I need to use that. That would have worked on my keyboard. All right, here's a word from our glorious leader, James. I like this tweet, actually, because it pretty much says everything I need to say about why we want to do this. I've got a couple of slides that go into more details, but what he's getting at here is there are 4 bullet points, right? I'm sure I probably would have put infrastructure at the bottom, so I might have had 5, but they're sort of levels in the stack, in a cloud stack, and they're increasingly, as you go up that stack, you get higher and higher levels of abstraction. And what that means, okay, if you're looking at it from the point of view of a Spring developer or a Spring user, is you care less and less about infrastructure and connections to other things and integrations, and more about business logic, okay? And that's something that we've been talking about in Spring since, like the year dot, right? Since when I joined. We both joined in 2006. And that was, that we had to go out and we had to educate people at that time. People didn't know about Spring. We had to spread the message, and the way we explained it was, you get to write the business logic, and we'll take care of all that messy stuff, all that plumbing, right? And so that was true then. That was true, 10, 12 years ago. And it's even more true now. So as you go up this stack, especially I'm thinking now because we're in a serverless talk, I'm thinking about going from apps to functions. The difference is that you leave behind a whole load of concerns that are not business concerns. So you really do get to the point where, what's a function, right? A function is you get some data, it's business data, and that's what makes it interesting. You operate on it, transform it, do something with it, maybe send it downstream. If that's what a function does, you're purely focused as a function developer on application logic, and that resonates with us, right? This is new, this stuff, function as a service, serverless, we're going to use them interchangeably. But as soon as we saw people wanting to do this, we knew that Spring had to kind of have an answer, right? Spring has to be there because this is what we've been doing since the beginning.
Yeah, and I would say even throughout the history of Spring, we've created layers to provide more opinionated, like as you go up the layers, things can become more opinionated and simpler for the developer, more responsibility taken on by the framework. But it's always a balancing act where you can still enter at lower layers when you need access to something like a direct database connection,
right,
as opposed to just using JDBC template. Right?
And actually hold on to that thought, because that'll be important later when he starts talking about Riff. But yeah, that's one of the reasons that we decided to do our own serverless platform is because of the sort of reasons that Mark's just been talking about, but he's going to talk about that later. So where that basically leads you is there are a whole host of reasons why people want to do serverless, and some of them are literally just because they're magpies and they like the shiny thing, and it's like, you know, Phil's picture in the keynote yesterday. And there are also a bunch of reasons connected with the platforms that actually have serverless capabilities already. So people might go to AWS Lambda because they want to use other AWS services. They want to use Kinesis and API Gateway and, you know, Dynamo and whatever else they can use in AWS.
And I think often the other direction as well. Their data is already in those
Their data is already there.
And now
right?
they can attach some logic to it every time something gets...
So there are lots of reasons why people are using serverless. And these are none of those, right? So these are what we've kind of picked out as kind of three key drivers for what we would think of as, you know, Spring users or Spring developers' point of view, enterprise application developers' point of view of serverless. Why would you go to serverless from, you know, let's say a PaaS, an app-centric approach? And it's three efficiencies, right? Do you want to introduce them?
Sure. So at the top layer, basically, is the developer efficiencies by having a much more reduced scope that you need to focus on as a developer. The next layer is actually the efficiencies at the resource level, because functions can scale down to 0, and basically when there's no data to process, they can idle. And so you can actually really have that auto-scaling capability to provide resource efficiencies. And then because you're relying on a service to manage the deployment of your applications, then there's also operational efficiencies. And I think for a while there was a term, no ops, and then that sort of has changed now into serverless ops. I think it's similar to the discussion around NoSQL. Yeah. Like anytime you put no in front of something, it's...
People get really, really worked up about names of things, right? And frankly, I couldn't care less. I'm happy to call it serverless, even though I know there's a server, right? I mean, I'm not stupid. None of us is, none of us is stupid. But there is a message there, right? It's telling me something. It's telling me, actually, this is another James Waters thing. He talks about the value line. How many people have heard James talking about the value line? Must be a few of you in here. That's useful, I think, to me. That speaks to me as an application developer about the things about which I do not care, right? I definitely, as an application developer, do not care if I'm running on Red Hat Linux or, you know, BSD. I really don't, right? I'm just a Java developer. I write my Java code and I run it in a JVM. Do I care what operating system it's on? Do I care if it's in VMware, OpenStack, you know, Google Compute, EC2? I do not care. I really don't. So that's quite a low value line, right? That's quite a low level not to care about. And we've sort of started to cover that sort of thing with various tools for producing platforms on top of those infrastructure abstractions. So as you go up the stack, though, things get more interesting. And actually, there's a quote that I like to put when I give this presentation from Adrian Cockcroft, who was at Netflix and drove some of their digital transformations, right? So he likes to talk about, you know, the drive to, he wasn't talking about serverless, he was just talking about basically platforms and why application code is what matters. And so his view, his quotable thing about the value line was you need to get out of the business of undifferentiated heavy lifting. You've probably heard that phrase, right? So undifferentiated heavy lifting for him in those days was, you know, virtual machines and infrastructure and, you know, gluing those pieces together at the infrastructure level. As we sort of develop these abstractions, as we mature our cloud usage, what we do is we raise that line above that stack to containers. I don't care about containers, frankly. I have no interest in building containers. I'm quite happy if they're being used, but I just don't want to have to deal with them. As you raise the level a bit higher, I think what serverless is telling us is there's even more you don't care about. The value line is even higher, and it's at the level of I don't care where this data comes from. I really don't care whether it's from an HTTP inbound gateway message or whether it's from a Kafka topic or RabbitMQ, or those are the kinds of things that you have to deal with when you write apps, right? You have to decide what your integration points are, and you have to glue things together. And sort of serverless is a way to break free of that and raise the value line above the integration glue that Spring is, has been our bread and butter, it's been our business, but really fundamentally all we cared about was just writing business logic, and that's where we're going to get to, right? A lot of people ask, what kind of things do I want, would I want to do with serverless? What makes it different? Why? There must be some use cases that work there that don't work with other platform abstractions. So we're not going to read them out, right? But I guess I've got one observation, then I'll let Mark jump in because I know he's got some opinions here as well. I'd just like to, I put the link at the bottom there. It's a link, when we share the slides, you'll be able to click on it, but it's actually Google, you can Google that and you'll find what I was pointing to. It's a very long link, which is why I didn't try to paste it in verbatim. It's from the Cloud Native Computing Foundation. They have a serverless working group, and they're writing a white paper, which is kind of interesting. And it's, it's an easy read. It's on Google Docs. You can actually, make changes to it or suggest changes to it, and they will accept or not. It's an open source document. But it's interesting, and it's got a whole section on use cases. Here are the things that we think are good candidates for writing in a serverless fashion, a serverless approach. And I know that there are some other...
Yeah, I would just add that a lot of times when you hear about serverless use cases, they're all very specific to public cloud providers and the services that are available in those environments. And we see already kind of emerging interest from our customer base, which is more of an enterprise focus in general, for even having capabilities on-prem to be able to integrate with traditional enterprise systems, your relational databases and your messaging systems and your file systems. So the same patterns can apply there, and that's why we think that it's important to focus on that as an abstraction that can be useful both in the public cloud and on-prem and in enterprise environments.
Yeah, and I guess because that's our bread and butter with Spring, I guess we're kind of hopefully well placed to help with that kind of thing. So who has serverless at the minute? Who's using it and who's offering it? So here's a sort of short laundry list. There are some hosted services. I've already mentioned a couple of them. AWS, Amazon Web Services was kind of the first. I think Google might have been kind of technically second, I don't know. And now we've also got Azure Functions, which is a very rich platform, quite interesting, lots of features, lots of nice Java SDK features as well. So those are hosted, and they come with the kind of the big beware sign on that you might suspect that perhaps they're trying to tempt you to use their other services. It's not just about serverless. Lambda wants you to use, Kinesis, and Azure wants you to use their own data services. But then there's an interesting other list here at the bottom of, what are your options if you wanted to run it yourself, okay, and manage it yourself. So the sort of open source community, as usual, has thrown up a whole load of options, and I don't even think this is the whole list. I put Oracle FN in there because I'm not sure of a hosted solution for that at the minute, but that's a recent entry. OpenWhisk is kind of IBM stroke Red Hat. And Fission and Kubeless are both Kubernetes-based fast platforms, as is OpenFast, I think, as well. OpenFast has got some interesting momentum. It's been quite sort of popular recently. And then at the top of that list is the thing that Mark was talking about on the keynote this morning, so Riff, Project Riff, which I think we should probably defer talking about. But
sure, there's plenty on that. Yeah. The only thing I would say here is that even though we are building Riff. We're also focused on, for Spring users with Spring Cloud Function, being able to create portable code that can run across all of these providers. So it's a very similar sort of modern version of what we did with application servers back in the day, right? We want Spring to be able to run everywhere and consistently so that you don't have to change your code, and we'll see a lot of that with Spring Cloud Function.
To the extent that that's possible, of course.
Right.
I mean, like, actually, with app servers, we were a little bit more fortunate in the sense that whether we liked it or not, there was the Java Enterprise Edition, platform was providing a sort of common substrate, at least in theory, maybe not in practice, but in theory, for all those things. Whereas these are actually quite different. So we will struggle to provide truly universal abstractions, but on the other hand, I think as you see features developing in Spring Cloud Function, you'll see that actually we might be able to give an interesting application-centric view, enterprise application-centric view of events in clouds that are pretty much the same across all of these platforms. That's the goal, at least, anyway. The events themselves and the way that you treat them in your programming model should be the same. That should be possible. Okay, so that's the background. That's sort of the stuff we were thinking about when we started this. Mark and I probably started thinking about it roughly the same time, kind of, I don't know, a year ago, something like that. So, we made these observations. For serverless, it's like Spring, isn't it? Everything's business logic, so we should be able to do something. So what would it look like if you were writing, instead of like the early days of serverless, everybody was just a web UI and you were pasting JavaScript in. Pasting JavaScript into a text box and hitting submit. And JavaScript is all functions, so that it's obvious that that's where it's going to land. If you were thinking about that as a Java developer, you probably would think of these things. So these are in the JDK, they're in Java 8, Java util function package. So you've got 3 patterns here: function, consumer, supplier, which is basically transformation, source, and sync and source, respectively. So we'd start maybe with these as building blocks, is what we thought. And then we thought, so we're Spring developers, how would those things manifest themselves? Well, obviously they'd be beans, and now people laugh at us outside Spring because they don't know what a bean is. But if you're a Spring developer, this is powerful, right? We know that @bean can express quite a lot of interesting features. I'm not showing them here, right? I'm not showing any interesting stuff like dependency injection, integration with, backend databases, configuration services. All those things are potential ingredients here. So this is a Spring Boot application, okay? It says on the top right, @Spring Boot application, which is executable in Spring Cloud Function. This is a function, which is a bean, and it transforms strings. It's kind of simple. For some reason, this is the kind of the poster child. This is the app that everybody writes, their first Hello World app with serverless. So what I'm going to do is actually build that thing and run it, if I can make the IDE pop up, which is it on a different desktop or something? That is there. Yeah, okay, whatever. So I'm going to do what Josh Long does, but using Eclipse. I'm going to do a new Spring project. Gosh, that's small. Is that too small for everybody to read? I don't think you need to read this, but you do need to read the thing that's behind it. We'll work that out in a minute. So I'm just generating a project anyway. You don't need to read what I'm doing. I'm going to call it functions. And I'm going to call the artifact functions, and I'm going to make the package name functions, because that might simplify things later. I can just about read that. Okay. Now I don't have Spring Cloud Function in the initializer yet in start.spring.io, but I'm just going to grab something from the cloud land, just cloud, what does that say? Cloud configuration. I'm just so I've got some dependency management. Spring Boot 159, that's fine.
I need to adjust the font.
Yeah, you can probably do that with keyboard, can't you? I don't know. Let's see when it comes up. We did this yesterday. It must have downloaded all those things then. Whatever.
I think you picked a lighter dependency. Maybe, I don't know if it's...
Well, something changed in initializer overnight, probably. We can blame Stefan. He probably pushed the change that upgraded everything. All right, so while that downloads,
There we go.
there we go. Hello.
I need to click for you as well.
You need to click for me. Yeah, I don't know how to click. I thought I had this working. I just tap it, don't I? It doesn't seem to work. How come it works? How come it works for you?
I don't know.
What are you doing? You're clicking, that's literally, aren't you? Yeah, that looks better, and I think I can make that bigger as well. Okay, here's my Spring Boot app. I already have everything on the class path I need just to write the bean, but I'm going to have to go and change some stuff to make it run. So at bean, Eclipse is probably just waiting there, is it? There we go. I do control space, right? Or do I do control space?
No, this is treating that as command.
Train that up. Command space?
Yeah. No, that should be control.
I thought it was. Oh yeah, there it is. Right, it was just slow the first time. At bean public function. Oh, I did the same thing again. There we go. Control space. Java util function of. I'm going to make it a little bit more interesting. I'm going to do, instead of string to string, I'm going to do pojo to pojo and call that uppercase. Just to torture myself. And then foo is going to be a class here. Class foo. Private string value and no, that's not working. Alt Shift S. Okay, should have practiced that. Source. Override. Generate getters and setters. That's all I need. Okay, done. Do I actually need to click key? Yes, I do. Getters and setters, and I'm going to have a constructor as well. String value. Interesting. This dot value equals value. All right, okay, so now we have a little plain old Java object, and I can return the function that converts a foo to its uppercase version. Value dot to uppercase. Yeah. All right, okay, so that's pretty much what I had on the slide, right? Now, at this point, I could run this, but it would be boring because it would just fall out the bottom of the main method and nothing would happen. So what I need to do is, this is functional code, right? This is business logic. It's very simple business logic, but that's all I should need to write. So this is the message from Spring Cloud function, basically. What I need to do to turn this into a real app that runs in the cloud is I just need to add some dependencies. So it's all about what's on the class path, which is quite familiar from Spring Boot, right? So I'm going to do one thing. Whoops, page up. I'll do one thing with properties. I'm going to do a Reactor.version because Spring Boot 1.5 doesn't have the new Reactor, and Spring Cloud Function depends on this version of the Reactor. That's correct, isn't it?
Yeah.
And then this, instead of being Spring Cloud Starter Console config, which I'd never really wanted, it was Spring Cloud Function. And then I can do other stuff that Spring Cloud Function specializes in. So in this case, I'm going to make a web app out of it with a minus sign in the right place, Spring Cloud Web. Save that, and it should build and be, oh, I need a version for that, of course, don't I? Because it's not, dependency is not managed. Version 1.0.0 build minus snapshot, you only live once. Right, so once Eclipse has recomputed the class path, now what I can do is I can, if I had my own keyboard, I would right-click, but I'm not going to do that. I'm going to try the shortcut, Alt-Shift, Alt-Shift-J. Yeah, Alt, there's Alt. No, that's not working. Okay, I need to run this thing. How do I do a right-click?
I can run it for you. I can be your function as a service. Boot app?
Thank you, Mark. There's a keyboard shortcut which is perfectly good, and I know what it is. Anyway, that makes it bigger, doesn't it? Yeah. Okay, so look, it's running. I'm going to have trouble actually showing that console. Sometimes you have to, yeah, it's a bit difficult, isn't it, even on mine. All right, so it's still running, which means that there's a server there somewhere. Look, Tomcat started on port 8080. That's because I said I wanted a Spring Cloud Function Web as a dependency. So this function has been wrapped up nice and cozy into a Spring MVC handler, and it's going to be able to accept curl requests, which maybe I can do in this terminal here if it wants to behave. I'll make that work. I have to do this, do I? All right, okay. So curl, make it nice and big, curl, local host 8080. So I have to post in a foo, right? I have to tell it value is hello San Francisco. That look good? Oh, do I need to tell it it's JSON? Well, normally I do. I don't know why I didn't do that this time. Content type application JSON. Let's hope that was it. Localhost 8080. Yeah, there you go, right. I can make it look neater. I can show you a curl trick minus W slash, yeah, there we go, N. Who knew that? Hooray. All right, so it converted the foo into an uppercase foo. So the business logic was wrapped and executed for me, where this is the slide, isn't it? Right, okay, cool. And so what you can tell from that, I'm not going to demo all the other different ways of doing that, but there are other ways of wrapping that function and making them executable. And so there's one that works in AWS Lambda, there's one that works in OpenWhisk, there's one that works in Azure, which is a pull request currently in the project. I'm going to try and show you that in a minute. And then there's one that does the web thing, so that's a standalone Spring Boot app running a web endpoint. Raid Sang actually pointed out, is he here? Pointed out that I could put that in Google App Engine Classic and call it serverless, because they scale down to 0 and they scale up as much as you want as well. So my Spring Boot app running a web endpoint is kind of a poor man's serverless. It's kind of interesting. And I can also run it. I think the most interesting one, you can do tasks, which are kind of, sources of data, if you like, do something, and it produces its own data. And a stream is what functions as a service all should be, but are not. And so that I'll drop that one in there, because Mark can talk about it later. And actually, the next slide's about that as well. So we've all been hearing about reactive streams, Project Reactor. So there's this other API called Reactor, which has publishers called Flux and Mono. And a flux is a stream of data, right? It's data coming in, which has kind of an identity all to itself, and you can operate on it. And in particular, you can do interesting things with it. Like Mark showed in the demo this morning in the keynote, you can window it. You can calculate what happened in the last 60 seconds. And then so the input might be 100 million events, and the output is 1 per minute. And so, stream operations are a very interesting paradigm for event-driven processing, and serverless is all about event-driven. So what we thought with Spring Cloud Function is we should be able to encapsulate that as well. All right? So we should be able to use these reactive APIs as well as plain old Java objects and functions. And so what we came up with was this. So what this is it's another uppercase function, but instead of being a function of string to string, it's a function of flux of string to flux of string. And in that function, I can then this isn't doing anything very sophisticated. This is just filtering out the ones that are not rude. So I'm going to get less data out than I put in, because some things will be swear words. But you could do other interesting things. This is, stream processing. So we decided to do that. And this exact application is the one that I wanted to show you next. So I took this application, which is basically the demo I just did, and I put it in a couple of the existing cloud platforms, one of which was Microsoft Azure. So let's have a look at that one. This is what Microsoft Azure looks like. You have a dashboard with function apps, and the sample app that I wrote here is that I deployed here is from Sobi Chaco did a pull request to Spring Cloud Function for Azure adapters, and so it's that sample in there. So it's this uppercase thing, and you can see in the dashboard on the right, you can tell if you can read it, which might be a challenge for everybody in the room, but it's going to be a challenge for me to display it all as well. This basically says script file, because it was originally a JavaScript function, and it's a jar file. Okay, that's a jar file there that ends in .jar. So I uploaded that from my continuous delivery pipeline called my laptop. And it has an entry point, which is a method reference, method handle to a foo handler. So instead of referring to it by bean, I'm referring to it by class and method name, but it's pretty much the same. It's the same code that I wrote in my demo. I'm just having to refer to the function class implementation itself. And then, okay, so I should be able to run an HTTP method post with content type application JSON, just like I did on the command line, value hello when I run it. I haven't run it for more than 10 minutes, so it's actually going to be a little bit slow the first time. But that worked, right? So I got an OK back. There's some logs there telling me that it's handled the request. I don't see the 200 sign, actually. I'm going to try that again. There we go. Actually, maybe I want to do, what I need to do is look at the monitor. Oh, there it is, right? 2 successful executions a few seconds ago. Actually, 1 a few seconds ago. I probably need to refresh to get the next one. And so it was sending back value hello in capital letters. It's a shame I didn't see that. I expected to see it in the console, but I'm sure it's there somewhere. The other thing I would like to show then before we move on to Riff is the same thing but running in AWS Lambda. So this is the AWS equivalent of that thing. This is a dashboard where I'm looking at my function. Lambda function's called uppercase, and I can run a test. I configured some test events, and one of the test events is called test, which has that value hello in it, I think, or value foo. So if I click that button, the same thing is happening here as happened in Azure. In fact, it's triggered, there we go. It started a JVM, started Spring. There's the log from Spring. Spring Boot started up. I didn't really need Spring Boot much in this app, but we're anticipating that some functions will benefit from having a Spring context, so that's one of the features we provide. It started Spring, and it cached the application context in such a way that when I run it again, if I can actually click the button instead of, there we go. When I run it again, it doesn't start Spring again, it just goes straight to the function, right? So you've got, this is the way that Java functions basically have to run in serverless platforms. They have to have a warm start. Otherwise, the latency is too high. But that was very quick, right? That was 6 milliseconds, whereas the first time it took like 3 seconds or something like that because I had to start Spring in the background. Okay, so that's actually all I wanted to say about Spring Cloud Function. We can perhaps move on to the next level of abstraction.
How much time do we have?
We've got half an hour still, so that's good.
Okay.
That's about right.
Okay, so I'm not really planning on going through all of the slides that I went through in the keynote this morning, because I assume most people were there. But I want to talk about a few different aspects of this, and then I want to show the installation experience using Helm and walk through a couple other examples, and then do a little bit of a deeper dive on what we were doing in the last demo that I showed this morning, including the Flux-based function there.
The one that actually had Spring in it, yeah.
Right. So as I did point out this morning, the goal with this is to allow developers to focus on functions and their event topics. And one of the things that we recognized when we started exploring the space is that there seems to be sort of trade-offs that you need to be able to make based on whether you are more concerned about latency or you're more concerned about resource utilization and so on. So we kind of came up with this idea of ICE as a similar in some ways to the CAP theorem, but I don't want to go too far with that. But the idea that you kind of have to lose one of these things if you're going to do the other two. So for instance, if you want to have completely immutable containers that don't do any dynamic loading of code, and you want those containers to always be instantly available, then you have to keep something running. If you want to, if you are willing to compromise on the immutability of your container, then you can dynamically load code into a pool of generic containers. And that's something that
by the way, I think is what Azure and Lambda are obviously doing. I mean, they haven't expressed their actual implementation, they haven't spec'd their implementation anywhere, but they're clearly doing that.
Right, and,
they have
other
resources.
Frameworks like Fission running on Kubernetes also take that approach of a pool of handlers that then have the functions basically dynamically loaded on demand.
And I think the way you can tell that that's what they're doing is that it takes less than a minute to get the first request, right? The cold start is actually faster than you'd think it was if they had to move all the container bytes and download them and start a VM and all that. So they've got warm pools of resources, they do.
Okay.
So they've made that choice. But we want to be able to give the
option. The
right?
idea for us is that we actually want to expose some of those options to end users, because it's not a one-size-fits-all kind of problem, right? You might have something where you are going to be experiencing very spiky data and sometimes long periods with no requests, but latency is so important that you want to keep at least one instance always running, right? There might be other cases where It's an infrequent task, maybe when a file arrives a few times a day, and you would never want to keep extra instances running, and no one's waiting on a response in a synchronous blocking way, so you don't care if it adds a few seconds for startup. So we want to expose those options as knobs, and I showed a little bit of that this morning, even in the current version. I think there are a lot more knobs for us to discover that need to be exposed, but for now, you can specify how long you want your idle timeout to be. You can specify how many instances you want to be able to scale up to for each function. And I pointed out this morning that this is really an example of inversion of control at the level of a container. So we want to be able to call your code from the invoker base image and take as much of that responsibility as we can on the base image itself. And our Java implementation of function invoker is exactly like what we just looked at across local as well as Lambda and Azure. We're using Spring Cloud function to call whatever function you've provided, which may or may not use Flux, but you have that option. And then we add the sidecar in the same pod so that we can handle the connections to the event broker without the invoker having to deal with that level of logic. So the invoker can be an HTTP server. It can be using standard I/O. And that's a contract, basically, between the invoker and the sidecar. Also, I want to go back on this slide for a minute to mention one of the things that, in the context of the ICE triangle, that we're starting to explore is the ability to have dynamically loaded functions on pools of invokers. And so even just looking at this diagram, you can imagine that instead of adding a layer into a pre-baked Docker image, we can actually add that function code to a volume mount that function invoker would then be able to access. And the code in the invoker wouldn't really be any different because it's just looking for that code at a certain location anyways. And so that's one of the things that we're exploring for dynamic pools.
So in that sense, the container is actually immutable, but there's some persistent data that you can change in a volume mount.
And even what we've already experimented with is being able to expose a Maven registry as the location of the volume mount. So even though the container is now mutable, the only thing that you're adding to it is a jar file that is itself also ideally the end of a CI pipeline.
So it's probably just an environment variable at the end of the day. You just decide which of the jar files in your repository you want to run by listing it in a manifest, essentially, declaring.
Okay, and then we use the custom resource definition extensions for Kubernetes to run all of this, which for us means that the actual RIF code base is as thin as it could be because we're relying on so much from the Kubernetes model. These controllers are basically registering a watch for the resources they're interested in, and then they receive callbacks anytime something's modified.
Kubernetes seems to be at the center of all of the open source efforts. Anybody who's doing serverless seems to need those features.
Some of the implementations aren't as opinionated about Kubernetes because they also want to run on other runtimes like Docker Swarm, for instance. But a couple of them are as opinionated as we are in terms of actually extending Kubernetes directly. Okay, and then I also showed this in the example this morning where the function scales from 0 to n, and n can be configured to anything up to the number of partitions on the input topic. And we're managing that by actually monitoring lag on the event broker. And so another item on our roadmap is to be able to have pluggable event brokers. So right now we're using Kafka, but we want, just like with Spring Cloud Stream, we want to take that binder abstraction and apply it here. That means that this monitoring functionality would need to be implemented for a number of different brokers.
I like the way your broker looks like Lego, by the way.
Yeah. Okay, and then here's the example that is a part of the example, actually, that was taken from the UI demo that I showed this morning. So this morning I showed the word count, which is a little bit more like generic and accessible, but this is the vote stream processor that's being used in that UI. And in fact, the vote stream processor has a couple different windowing operations. This is the one that creates the shifting windows. So you can see that Flux provides a window operation, and this window operation that we're calling has two separate duration parameters. The first one is the size of your window, and the second one is the time shift. So it will emit a result every 2 seconds, but that result will be the count of the preceding 60 seconds. And so it doesn't matter, as Dave pointed out before, it doesn't matter what the input frequency rate is, the output frequency is always going to be 2 seconds.
Every 2 seconds.
And sometimes it will emit an empty map because it didn't receive any data.
Well, it's actually every 2 seconds per word, isn't it? Is that the way it was expressed?
Well, it returns a map
It's a
of
map
all
with,
of the
okay,
words.
right. So every 2 seconds you get a map with all the words.
Right. OK, so let me go ahead. I'm going to start completely from scratch so that you can see what the getting started experience would be like. In fact, I think, yeah, I wanted to show the page here. So if you go to the GitHub org project Riff, we have the sort of umbrella project itself is called Riff. And Riff has a getting started guide as well as the README with other links. And it has some scripts that you can use and some configuration YAML if you want to deploy things locally using kube control directly. But we typically recommend the Helm install if you're going to be pulling down the images that we'll be publishing to Docker Hub. So currently we have the 001 release, which was, I think, sometime last week. If we look at Helm init, and then I've already added this repo, but the command for the Helm repo would be right here. So Helm repo add, and then you point to our charts, which are just on a Google Cloud Storage folder. And then you update the repo, and then you can do Helm install riff repo riff and give it a name. Sometimes, if you have a Kubernetes cluster that is using RBAC, then you would need to specify set RBAC equals true. And also, if you're using Minikube running locally, then you would want to set type equals node port for the HTTP gateway. Otherwise, the default type is load balancer, which is what you want when you're running on, say, GKE or public cloud. OK, so let me run.
How's the font size at the back?
Make it bigger. Is that good?
Equivocal. Could be bigger. That looks better.
OK, so I'm going to add the HTTP gateway node port. And then on the bottom, you see the deployment starting. And so this is the naming convention with Helm. So we see each of the components of Riff being prefixed by the name that I used for this release. Right, so you can do upgrades and you can do deletion of a named release. You could actually install Riff 3 different times using 3 different names on this cluster. Maybe not on my Minikube, but if you're running on GKE. OK, so the function controller is watching for function resources. The topic controller is watching for topic resources. And the HTTP gateway is providing web endpoints for sending events to topics. And now what I'll show you is some of the samples that come with, if you clone the repo. So very similar to what I showed this morning, but I won't be starting from scratch so that you see what's in here. So we have the echo function. The echo function is going to return received, whatever you pass it. There's a Docker file here which shows the shell function invoker as the base image. And there's the YAML file for the topic, greetings, which has 3 partitions, and for the echo function itself. And this is the image that you create using that Docker file. So there's 2 steps, basically. This morning, I was using a script that called both of those independently. But you do riff build to create the Docker image. And then you do riff apply to pass that YAML into Kubernetes. And now you see the echo was deployed with 0 instances. And it's listening to the greetings topic. And so this will go through the HTTP gateway and send a message to echo. And this is that was the cold start, basically. And now it's running until it times out. And the timeout is configurable, but 10 seconds by default. Okay, so we have a few other samples that you can look at. There's a word count there. We have in the node directory, we have the square sampled similar to what I showed this morning. There's a Python example and a example that actually creates a Slack bot. And then there's a Java example in here, but I think the more interesting one is the one from the demo this morning. And I've got the full code for that in here. This is what you saw on the slide just a moment ago, but we'll expand this. Okay, so the actual function here, the apply method, is just doing a flux merge operation on two other functions. So this is how I get the 2-second windows as well as the 60-second shifting windows. And then for convenience, I just created a POJO here that basically creates the aggregate and provides a sum operation so that I could refer to it here. And one other thing that this does is when it creates the map to emit, it's actually putting a different key into that map depending on whether this is the 2-second window or the 60-second window, so that our UI can refer to those two keys within Redis and render the data accordingly. Okay. I don't think I need that anymore.
And so did you say when you deploy this, it takes data from Kafka and puts it back in Kafka in a different topic, presumably?
Right.
Yeah.
Yeah. Yeah, so the vote stream processor itself is not talking to Redis. It's reading from the votes topic, and then it's writing to a topic that a JavaScript Redis writer is listening to.
Via a sidecar, of course.
Okay, so I'll deploy the functions. The Redis writer itself, which is the JavaScript app, the vote counter, which is also a JavaScript app, and then the vote stream processor, which is the Reactor Flux app that's using the Java invoker. And then I deploy the UI, and we'll see it's the same thing that I showed this morning. Oh, wow. It's got some crazy data in there.
What's that?
These are things that got sent. Wow. I'm not sure. Okay, well, let's go to this one for a minute.
Right.
So this one's running on GKE, and you can see the shifting windows. On the bottom, we can create some events. This is also available in the booth if you want to try it out there as well. And you can see the background images, the shifting windows, and then each line in the bar graph is a 2-second window. These meters indicate how many partitions we have. So if we look back here, you see vote stream processor scaling up to 6, and now it's scaled back down. So that's the demo, and I think I have maybe one more slide.
So that little dashboard was Kubernetes deployments, right?
Right. I just have a watch on kube control git deploy, right? So I can see the deployments.
So it's all deployments in the default namespace, basically.
I can also look at things like the topics and the functions.
Right.
Right. So you get all of this for free if you define custom resources. You're able to use the kube control API to create those things and delete those things. The rif command is just a convenience that handles that for you, but you can also do it directly with that YAML. Okay, so that's the demo, and I think it looks to me like we're
doing pretty well.
Out of time. Yeah.
Ah, good.
Okay, but we'll be around and definitely interested in having any conversations, taking questions. We'll be here even through tomorrow as well. So,
yeah.
thank you.